we are going to hear from Martin Taylor, who's the CTO at Metaswitch, which last year became part of Microsoft. And therefore, he's very well placed to talk about are hyperscalers and telcos natural friends or enemies? Thank you, Martin.
Thanks, Annie. You stole my first few words of self-introduction, but that's fine. As Annie said, I work for Metaswitch. We are a vendor of network function software, mostly in the voice, but also emerging in the 5G space. And we were acquired by Microsoft back in July last year. So I kind of straddle the two worlds of network functions for telcos and obviously now part of a hyperscaler. And the question I'm addressing here is really about what does the relationship between hyperscalers and telcos look like? And probably, you know, what we'll agree is that it looks somewhat like co-opetition. But what I'm going to do here is kind of explore the dimensions of that. So let's just talk about what we're going to talk about. I'll say a few words about the public stance of the big three hyperscalers. You know, what they've said in public, and of course what they're doing in offering communication services that potentially compete with telcos. And then I'm going to drill into 5 specific areas where telcos meet hyperscalers, and there is opportunity for constructive partnership, but also, of course, opportunity for potentially for friction and competition. So let's start talking about, well, you know, what have the big three been doing here? And I would say, and this is all in the public domain, if you're following this space, you've observed over the last year or two that the big three hyperscalers have all announced telecom partnership strategies. I think that they see telcos as, in some ways, just like any other enterprise, that you know they're seeking to offer a platform for hosting IT applications, just as they would for a bank. But there's an additional opportunity with telcos, which is around hosting elements of their network in the public cloud, which I think, you know, makes telcos a somewhat different kind of customer proposition from the point of view of hyperscalers. So there are additional opportunities here, but there are, of course, additional challenges. And some of those challenges are around the sort of technical aspects of getting telco network functions running on public cloud successfully, but also around, you know, all the kind of expected areas of friction, things like data sovereignty and security, and you know, the just sort of feeling the ownership of control and so on. Now, it's worth pointing out that in some senses, the hyperscalers compete with telcos in some very specific areas. I mean, all three have very, very large global networks with a lot of capacity interconnecting their data centers, and that includes, you know, lots of transoceanic fiber capacity and so on. So in that sense, the hyperscalers are carrying traffic that, you know, might otherwise be carried by telcos on their own private networks. At least one of the hyperscalers is actually offering retail broadband and phone services. That's Google Fiber. I mean, I think there's an open question here about what is the future of that. I mean, just as a sort of observer, it would appear that Google has found the business model of providing retail broadband services quite challenging, and they seem for the moment at least to have largely capped their footprint, but who knows, you know, where that might go in future. But that's obviously an area where Google at least is competing very directly with telcos in their traditional markets. And then in sort of emerging services like unified communications, I mean, the telcos are and have been quite active in this space for quite some time now, with products like hosted PBX evolving into unified communications and collaboration. and vendors like ourselves and Broadsoft, now part of Cisco, have been serving the software market for telcos to enable them to offer those kinds of services. And I think you could reasonably regard Teams and Google Meet and those kinds of services as somewhat competitive with what the telcos are offering. But I think, we'll talk a little bit more about that and see whether there's opportunities for constructive partnership in those kinds of spaces. Now, if you listen to the rhetoric coming from the hyperscalers, what you'll hear is, we want to partner, not compete. I mean, that obviously makes perfect sense, and you probably would expect the hyperscalers to say that, wouldn't you? Because they view telcos as a potentially big revenue opportunity, and they don't want to put them off by positioning against them in their traditional markets. Okay, so let's start the drill into the 5 areas where I think it's interesting to look at hyperscalers and telcos working together. And the first one is around NFV infrastructure in public cloud. Now, hyperscalers clearly have been talking to telcos for quite some time about moving their back office operations and kind of traditional IT stuff, billing, customer relationship management, OSS, BSS, those kinds of things, which you can view as traditional IT workloads, which clearly there's a business case for moving those into public cloud and off of telcos' own facilities. So that's kind of business as usual for hyperscalers. But the NFV infrastructure thing is really a new opportunity for the hyperscalers. And the observations I'd make here, and we've been in the business of supplying network function software to telcos for many, many years. I mean, 30 or 40 years in this business. And of course, very, very close to the NFV evolution that's been going on since 2012 or so. I mean, some people would view us as very much as pioneers in that kind of cloud native approach to building network functions. But we have seen telcos really struggle with this. I mean, it's fundamentally building and operating private cloud, particularly for NFV, is really difficult. The technologies are extremely complex, very challenging to work with, and somewhat resistant to standardization. So the industry has spawned lots of efforts like the ETSI NFV thing, the OP platform for NFV, the CNTT, which has changed its meaning so often I've slightly lost touch with what it means now, but it's something to do with cloud native for telcos. These things, I mean, they've helped a little bit, but they haven't made things fundamentally easier for telcos to build these clouds. And as we look forward, and everyone is very focused now on cloud native as the right way to do NFV, that implies an evolution of the cloud technology to add Kubernetes and containers and all that. And that just makes things even harder, because now we've got containers and cloud native applications running alongside kind of more traditional ported appliances running in virtual machines. So it doesn't get any easier. When you look at public cloud, I mean, effectively, telcos could view public cloud as a way of outsourcing their NFV infrastructure, leveraging the massive investments that hyperscalers have made in building out huge data centers and investing enormously in the cloud stack and the operational automation that allows the hyperscalers to operate these clouds at much, much lower cost per compute resource than telcos ever could. So those economies of scale are available to telcos if they choose to put network functions in public cloud. But there's another very important aspect here, which is one of the big differences between public cloud and private cloud is that public cloud offers a massive set of platform capabilities that are there for the taking. And particularly around analytics and machine learning, and being able to take data that is being generated by telco network functions and do useful stuff with it that helps telcos to innovate in the operational space, become more efficient, but also understand their customer behavior better than they currently can. they would otherwise have to invest themselves in a lot of these tools to put them on their own private clouds. And again, that's very difficult. So having access to these tools gives them the opportunity to very quickly prototype new kinds of analytics and machine learning applied to the data that their network functions generate. Now, I say at the bottom, many telcos are now actively exploring this. That's absolutely the case. We're in lots of conversations. One of the dynamics we've observed here is that there's a variety of different things going on. One is that there's a set of very kind of legacy network functions which are typically running on dedicated hardware right now, viewed by telcos as cost centers, not interesting from the point of view of revenue, but they have to offer them. And voicemail is an incredibly good example of that. I mean, no one cares about voicemail anymore, but it absolutely has to be there as part of the offering. It doesn't generate any revenue, it's just a cost. So moving that into a public cloud, just kind of washing your hands of it, if you like, and just saying, okay, job done. We're not going to sink any more kind of cost in innovating, operating in that space. That's the very active conversations going on that. And then you also see kind of leading edge stuff. So people looking at 5G standalone packet cores, particularly for things like IoT. This is brand new greenfield deployment. Okay, let's look at, well, public cloud versus private cloud as a different kind of place to host that. There's new greenfield rollouts. Okay, so that's the NFV infrastructure topic. Next is the edge, and of course a huge amount of interest in this, and some might say hype in this area, but clearly investments are being made. A lot of interest in edge as part of the monetization of 5G. If all that 5G ever delivers is enhanced mobile broadband, from a telco point of view, it's okay, we have to invest in it, but it's not going to give us much return. There do appear to be opportunities for new kinds of applications to be supported at the edge around low latency and around reducing the amount of backhaul bandwidth by doing things like video analytics close to the sources of data. And what you see when you look at the edge is two parallel streams of activity. You've got the operators looking at what network functions they need to deploy at the edge to support their networks. The 5G user plane function, the control unit of the RAN, things like AGF and BNG for wireline broadband, carrier grade NAT, that kind of stuff. And then they're also looking at, well, what does the private cloud look like at the edge? Is this some sort of evolution of OpenStack? Do we use VMware? There's a bunch of open source projects which are kind of building templates for what the stack might look like, very sort of OpenStack-like in general, but evolving to containers. And then on the hyperscaler side, sorry, I don't know why that hopped ahead. Maybe there's a hint here that I'm taking too long. On the hyperscaler side, you've got a whole bunch of applications that they already have a lot of technology for. So Microsoft, huge in video analytics and video augmented reality and so on, gaming, lots of technology there, which it makes sense to deploy at the edge. And of course also extensions of the public cloud environment into physical edge locations. And again, all of the big three have announced various initiatives here. Given how it appears that the business objectives of the telcos and the hyperscalers are quite well aligned at the edge, you would expect there to be lots of opportunity for cooperation and partnership. But I think the problem is that nobody really knows what that looks like. Nobody knows what applications are really going to take off. Nobody knows really what kinds of cloud infrastructure are going to make sense here. Nobody knows whether it's going to be important to co-locate the applications and the network infrastructure, or whether in fact they can just be connected by local fiber, within the same city, and that's going to be good enough from a latency point of view. So lots and lots of unanswered questions here, but again, lots of scope for cooperation and partnering in our view. Okay, private 5G. So this is very much an emerging area, and I think a really interesting one from the point of view of operator hyperscaler dynamics here. private 5G, and of course, there's private LTE out there today, and that will continue to be important. But I think 5G is seen as a technology that will enable a bunch of interesting new possibilities in private networking. So we're talking about enterprises deploying 5G radio access networks as a means typically of supporting a variety of IoT applications, and that might include video surveillance, it might include robotic control, it might include just providing communication services across large sites like transport hubs, airports, ports, that kind of thing. So a lot of activity going on here, a lot of prototypes, a lot of pilots being rolled out. And operators and hyperscalers are really coming at this from almost diametrically opposite ends of the whole initiative. Operators would say, look, we bring spectrum, we've got existing mobile networks, we know a lot about how to build out radio access networks, and they really want to leverage what they've invested in terms of 5G. So their ideal picture is we'll use our 5G packet core control plane in our telco cloud, and we'll put the user plane function at the edge because we want to keep the data local. But we're going to leverage our existing 5G network know-how and our spectrum. So they're coming at this as private 5G is kind of an extension of our network. Hyperscalers are coming at this much more from the point of view of, we have a ton of IoT technologies. A lot of the hyperscalers have got big IoT platforms already, lots of relationships with enterprises in these application areas, big ecosystems of developers around these kinds of applications, and as I say, lots of platform capabilities for IoT. So they are viewing private 5G as a new kind of network for accessing assets that they can offer in the cloud. Very, very different mindset. Now, the value that you might place on operator assets, particularly spectrum, depends a lot on what territory you're in. So, different countries have different regulatory environments for spectrum. If you look at the US, CBRS, makes it very, very easy to deploy your own private 5G network. That's true also in Germany. UK has a pretty liberal licensing scheme for private networks. Some other countries are much more kind of restricted, if you like, and operators may have an advantage there. They've lobbied the regulator successfully to enable them to keep control of the spectrum, so they will tend to have a bigger part to play. There's no question that there's going to be a lot of cooperation here, but I think I'm tempted to believe that hyperscalers, with their enterprise IT relationships and their system integrated relationships, who's going to build out these RANs? We need system integrators to help us do that. Are going to find this an easier market to tackle than the telcos. Okay, next one is around footprint expansion. So the observation here is that lots of tier ones particularly serve global enterprise customers, very important and profitable market for them. When they provide services out of territory, they typically have to work with a lot of local telco partners. So, if you sign up with, let's say, Verizon as a global enterprise, your headquarters might be in the US, but you have big offices in London. Verizon Global would effectively have to work with some local partner to provide connectivity in and maybe service capabilities in London and other cities that the enterprise has facilities in. So with public cloud, this offers an interesting new opportunity for telcos to roll out a local presence of some kind. Now, they still need connectivity, but and they'll have to rely on partners for that. But they can grab more of the value chain here, and they have more control over the service that's being offered. So, for example, they can deploy provider edge routers, they can deploy session border controllers, they could even deploy telephony application servers, messaging servers, those kinds of things locally to the enterprise locations, leveraging public cloud and its global footprint, rather than relying on local telco partners who clearly have a much bigger chunk of the value chain. So footprint expansion appears to offer a clear win-win for telcos who are successful in this global enterprise communication space. And finally, the communications services space. So as we said earlier, hyperscalers all have offerings in, you could generally describe as unified communications and collaboration. Arguably, Microsoft is the leader here. I mean, Teams is super important product, and of course during the pandemic, has grown extraordinarily fast. But also Azure Communication Services, for example, offers APIs that enable you to leverage Teams as a communications platform and build new services on top of that. Google and Amazon, also have services in this space. So you could kind of view these as indirectly competitive, but they are addressing needs that have not traditionally been met by telcos. So many telcos have been offering hosted PBX kinds of services that look much more like traditional telco voice. Those have certainly evolved over the years to kind of add messaging and presence and video and those kinds of things, but they're not exact equivalents of what products like Teams and Zoom can offer. So, but equally, you can argue that the UC&C products available from the hyperscalers and others are not really complete replacements for enterprise telephony needs. There's quite a big gap, when it comes to things like call centers and so on. So there's actually plenty of scope for partnership here. I mean, essentially, if you look at the complete spectrum of enterprise needs for UC&C and telephony, arguably the telcos are in a better position to meet the telephony requirements. Arguably, the hyperscalers are in a better position to meet the UC&C stuff. But you can absolutely imagine a situation where a telco partners with, let's say, Microsoft, resells Teams in conjunction with a well-integrated hosted telephony service, and there's real value in that kind of thing. So we're seeing a lot of interest in that. Now, from the point of view of, well, what does it actually look like from a service point of view? Still lots of kind of evolution to happen there, lots of head scratching and hard thinking, but there's clearly lots of scope for positive business relationships and cooperation. Okay, so just to very briefly wrap up, we think telcos have a huge amount to gain from partnering with hyperscalers. So they should view hyperscalers as natural friends, reducing the pain and cost of NFV infrastructure. Really, how do you monetize the edge? Well, you have to attract a healthy ecosystem of applications and developers. Hyperscalers can help hugely with that. Enterprise needs for private 5G, very interesting new market. Hyperscalers clearly have some huge advantages here, but telcos have a part to play as well. Out of territory local points of presence, combined UC&C and telephony, these are all interesting areas of cooperation. So that's all the kind of formal material I had. Very happy to answer a couple of questions in the short remaining time that I have. Annie, do you want to?
Thank you, Martin. I've got a couple of questions from our audience. One person asks, moving NFV from on-premise to the public cloud would need the applications to be modernized, as many are not cloud native, and who will take care of that? And also, are the users NFVs certified for use on the public cloud?
Yes. So you don't have to be cloud native to run on public cloud, although it obviously helps. I mean, there's no question that it's difficult to take a network function that was certified on OpenStack and built to run on OpenStack and just port it to a public cloud. There are going to be some differences in the underlying infrastructure that are going to require the network function to be adapted. And I think this is purely a question of market pressure. If enough telcos go to their network function vendors and say, we love your network function, but we really want to run it on public cloud, then the network function vendors will respond to that. There's also some investment that I think the public cloud operators need to make in making the public cloud a better place for telco network functions. And I think you'll see some innovation in that space over the next year or two. I can't say too much about that, but I mean, there's no question public cloud and network functions need to kind of meet in the middle somewhere, but that's very actively going on.
Okay, and someone else asks, where do you see Open RAN sitting the best, with the operators or with the hyperscalers?
I mean, I think both are going to see ways to leverage Open RAN technology to advance their respective needs. I mean, as I say, it doesn't appear as though the hyperscalers are likely to roll out large-scale RAN investments of their own. I mean, certainly they're going to be active in the private cellular space, and Open RAN may have a role there. So, but I think generally Open RAN, you know, my view is it's still relatively immature, still a lot of challenges. It's probably ready for a bunch of niche applications, and private cellular is probably one of those, but maybe not ready for prime time in mobile broadband.
Okay, we have a couple more questions here. A member asks, have you any telco references already on the public cloud? If so, for which VNFs, and can you name them? And if we haven't got references, have we got any proofs of concept we can cite?
Yeah, so no, I don't think there's anything in the public domain that I can talk about. I mean, what I can say is that we are in the process of standing up a mobile voicemail system with many tens of millions of mailboxes for a tier 1 mobile operator that's on Azure. I can't say who that is, but that's a good example of taking a legacy application, which is no longer of any great interest to telcos from a revenue standpoint, and kind of outsourcing it, if you like. Now, there's some interesting questions around, well, what's the business model for that? Is this the telco managing the application on public cloud, just treating public cloud as a hosting environment as opposed to private cloud? Or does this look like mobile voicemail as a service, which is actually being operated by the hyperscaler? And I mean, in this particular case, it's not mobile voicemail. It is the telco treating the public cloud as an alternative to a private NFV infrastructure.
Okay, and the final question, Martin, because unfortunately we're short on time.
Yep.
What challenges do you see for assuring end users quality of experience when telcos use public cloud to host network functions?
Yeah, so I mean, there's always been a debate in the industry about, do you need sophisticated QoS capabilities in your network, or does brute force eventually just make it easy to guarantee a good quality experience? And I mean, history shows that brute force always wins. I mean, ATM was a classic example of let's use lots of sophisticated, clever stuff in the network to absolutely guarantee super quality of experience. It was so complicated, and the speed with which technologies like Ethernet evolved just meant that brute force won out at the end of the day. I mean, I'm talking to you today over a 200 megabit fiber connection to my home. There's no quality of service on that, but it's pretty good, isn't it? So I would say at the end of the day, the hyperscalers will deliver a very good quality of experience simply by virtue of having massive scale on their side. Okay, Martin, thank you. Great presentation. We really enjoyed it. Thank you so much. Okay, pleasure.